This one is yeah, you haven't got a kind of a boundary here with a hole. You're just marking these sevenths on a number line, and because they're sevenths there, they're kind of a bit awkward anyway, aren't they?
Where's 3/7?
Looking at the first one, if I know where 2/7 is, then I know that 1/7 is half of that. So if I kind of added half one again, that will put me at 3/7. Doing B, I know I've got 4/7 and 6/7, so there's a kind of 2/7 gap between those two. So I could put 5/7 in as being halfway between, and then I could go back. So that difference between 4/7 and 5/7 is going to be 1/7. I could go back 1/7 from 4/7.
I think A is helping set up that strategy for doing B, isn't it? Because A, you're looking at being able to find 1/7. Once you know 1/7, you can do the rest of it. And then B, you're still looking to find 1/7, but that 1/7 is more concealed, isn't it? It has to be the difference between the 4 and the 5, or the 5 and the 6.
Well, I'm asked for 3/7. I've got 3/14. So I suppose something that I might think about is that 3/14, well, a 14th is half as big as a 7th. So 3/7 has got to be twice as big as 3/14. So I would just kind of I go the same distance beyond 3/14 as I've got the 0, and that would give me 3/7.
With this task, it's so easy for students to fall in the trap of thinking that 3/7 would be half the size of 3/14 rather than double the size. It also brings out the strategy of being able to work with common numerators. We quite often go to common denominators as a very successful tool for working with fractions, but actually when you're comparing quantities, looking at common numerators can also be something to have in our toolkit.